a mysterious planet has piqued the interest of scientists and space enthusiasts alike. The James Webb Telescope has just announced the clearest image of Proxima B seen in history. What secrets does this distant world hold? Can it support life? Let's delve into what the James Webb Telescope has revealed. Looking back billions of years into the universe's history, we can glimpse how galaxies came into existence. With the James Webb Space Telescope, JWST, we can take that principle to the next level and explore the furthest reaches of space. The infrared images captured by the JWST are unlike anything human eyes have ever seen before. The telescope's capabilities depend on how it's utilized. Much like a Snapchat filter on your phone, the James Webb Space Telescope enables astronomers to study the early universe and better understand the birth of galaxies, stars, and planets. Researchers can analyze the hues in those images by using the telescope's camera and filters to gather a specific range of light colors. The JWST will also investigate the atmospheres of planets outside our solar system and search for indications of extraterrestrial life. Its ability to look further back in time and space than ever before has led to significant findings on the evolution of the cosmos. For example, astronomers used the telescope to discover more mass than previously believed to exist in the universe, hidden away in several massive galaxies. The James Webb Telescope has just announced the clearest image of Proxima B seen in history. In 2013, astronomers detected hints of a tiny gravitational tug exerted by a planet on its star. After years of searching, the planet, which orbits Proxima Centauri, was later named Proxima B. The discovery of this planet is fascinating since it orbits the closest star system to us after the Sun, observing the Alpha Centauri system, which is around 4 light-years away from us, provides a glimpse into the past since we are seeing it as it was 4 years ago. Proxima B certainly takes the cake when it comes to exciting astronomical discoveries. This planet is located a mere 25 light-years away from Earth, making it one of the closest exoplanets ever discovered. But don't let the distance fool you. Proxima B is a whole different world from our own. The planet is about 30% more massive than Earth, which means it's bigger too. But don't let that fool you. Proxima B's year only lasts 11.2 Earth days, which is super short. That's because the planet orbits its star, Proxima Centauri, at a distance of just 7.3 million kilometers, which is less than 5% of the distance between Earth and the Sun. You might be thinking that a planet so close to its star must be boiling hot, but Proxima Centauri is a tiny red dwarf star that doesn't radiate nearly as much energy as our Sun. So what would it be like to stand on the surface of Proxima B and gaze up at Proxima Centauri? The star would look like a dull red orb, roughly 3 times as big as our Sun, and if the planet is in its star's habitable zone, which it appears to be, it might have the right conditions to support liquid water. But before you start packing your bags for an interplanetary adventure, you should know that Proxima B is far from a second Earth. For one, the planet is likely tidally locked with its star, which means one side faces the star while the other is always in darkness. That's definitely not a comfortable environment for any potential life forms, and any water that comes too close to the star would be boiled away by its powerful radiation. On the other hand, if a planet is too far from its star, it won't receive enough heat and all of its water will freeze. Proxima Centauri might not be as friendly to life as we thought. Despite having only a fraction of the Sun's mass, its small size causes its nuclear fusion core to be much closer to its surface, resulting in chaotic and turbulent surface activity. This activity leads to extremely powerful magnetic fields that produce high-energy radiation and particle bursts, posing a significant challenge for planets like Proxima B that orbit within the star's habitable zone. While scientists had some knowledge about the magnetic field conditions around nearby stars, they were in the dark about the precise conditions around Proxima Centauri until now. Thanks to a recent study using high-resolution magnetic field maps, we better understand the star's solar wind and the dire situation on Proxima B. The study revealed that the planet receives roughly 1,000 times more solar wind radiation than Earth, putting any potential life at risk from powerful flares. In fact, a Proxima Centauri flare in April 2021 was 100 times more potent than any flare ever observed from the Sun. It's hard to imagine life surviving such intense radiation without specialized shelter. While the idea of a habitable planet orbiting Proxima Centauri is captivating, the reality seems far from hospitable. As humans, we have always been fascinated with the possibility of encountering extraterrestrial life, and in late 2020 that fascination reached new heights when a peculiar signal was discovered originating from the Alpha Centauri system. Interestingly, this signal reads at an unusual frequency of 9,827 MHz, which is not typically associated with signals from Earth-based satellites and spacecraft. While some experts speculate that a piece of manufactured equipment may have caused the signal, others continue to dream that it may be proof of intelligent life traveling to Proxima Centauri, the nearest planet outside our solar system. Encountering alien life may not be as far-fetched as once thought. The breakthrough initiatives have been researching the possibility of cutting down travel time from hundreds of years to just decades. Recent research highlights how current technology could potentially overcome the challenge of accelerating an object as its mass increases, particularly as it approaches the speed of light. Despite this, Alpha Centauri being the closest star system to Earth would still require around 6,000 years of travel time with current technology, making it a daunting journey. Starshot, a project aimed at reaching Alpha Centauri, the nearest star system to Earth, is considering using lasers to propel a spacecraft toward its destination. However, the main challenge lies in Earth's atmosphere, which affects incoming light and laser light, making it difficult to exert the necessary force to move a spacecraft forward. Body, the paper's first author, suggests that adaptive optics could be used in reverse to overcome this challenge. Small lasers on satellites would assess atmospheric effects in real time, allowing much more powerful lasers on the ground to maintain a tight focus on the space probe. The required lasers need a whopping 100 gigawatts of power to send the vessel at any given time, which is equivalent to the entire electricity consumption of the United States. However, the lasers only need to run at maximum capacity for 10 minutes to disperse the electricity across a kilometer-square region. They plan to use 100 million lasers. The Starshot team is determined to push the boundaries of space exploration. The object hurtling through space will be moving at an astonishing 20% of the speed of light. When the lasers are turned off, this spacecraft would be a little over 10 meters in diameter and could reach Alpha Centauri in just 22 years. However, the gravitational pull of the Sun and interstellar debris may considerably slow it down. Even if the spacecraft reaches Alpha Centauri, its transmissions will take another 4 years to reach Earth. Bope and Siegler know that keeping the probe from melting is one of the biggest challenges. To prevent this, the mirror on the spacecraft must be practically perfect, reflecting 99.99% of the light that strikes it. Additionally, it needs to double the momentum transfer while decreasing heat in a matter of days. Once launched, the probe would traverse the Alpha Centauri system, likely never getting very close to a planet. The fascinating part of this concept is that once the launch system is in place, more probes may be sent for a reasonable price. The chances of catching a fleeting glimpse of any Earth-like planets are significantly increased if a fleet of probes floods adjacent star systems. Imagine the possibilities. After arriving at Proxima Centauri, mankind would have an entire star system to explore. How many additional planets like our own might there be? Exoplanets are planets that orbit stars outside our solar system, and the discovery of these distant worlds has revolutionized our understanding of the universe. Thousands of exoplanets have been identified since the early 1990s, revealing a surprising diversity in planetary systems and their characteristics. This journey of discovery began in 1992 when scientists made the first official findings of planets circling a particular class of neutron star known as a pulsar. This groundbreaking discovery was unexpected because pulsars are remnants of supernova explosions, characterized by their intense radiation and rapid rotation, making them seemingly hostile environments for planet formation. The pulsar planets were a curious find, but the quest for planets orbiting stars similar to our Sun continued. In 1995, this quest bore fruit with the discovery of 51 Pegasi b, the first exoplanet found orbiting a Sun-like star. This planet, located about 50 light-years away in the constellation Pegasus, was a hot Jupiter, a gas giant orbiting very close to its star. The detection of 51 Pegasi b marked a significant milestone, proving that other solar systems could indeed exist and could be very different from our own. Since then, the search for exoplanets has expanded dramatically, aided by advancements in technology and observational techniques. Ground-based telescopes such as those at the Keck Observatory in Hawaii have played a crucial role, but it was the launch of space-based observatories that truly accelerated the pace of discovery. The Kepler Space Telescope, launched by NASA in 2009, was particularly transformative. Kepler monitored over 150,000 stars in a small patch of the sky, looking for tiny dips in brightness caused by planets transiting or passing in front of their host stars. Kepler's mission was extraordinarily successful, identifying over 2,600 confirmed exoplanets and thousands of additional candidates. These discoveries included a wide variety of planets, from small rocky worlds similar in size to Earth to enormous gas giants much larger than Jupiter. Kepler's data revealed that planets are common in the Milky Way galaxy, with an estimated 1 in 5 Sun-like stars hosting an Earth-sized planet in its habitable zone, the region around a star where conditions might be right for liquid water to exist. Among the numerous exoplanets discovered, several have garnered particular interest because of their potential to support life. These are primarily Earth-sized or slightly larger planets located within their star's habitable zone. One notable example is Kepler 186f, the first Earth-sized planet found in the habitable zone of its star. Located about 500 light-years away, Kepler 186f orbits a red dwarf star and receives about 13% of the energy from its star that Earth gets from the Sun. Its discovery was a major milestone in the search for habitable worlds beyond our solar system. Other missions have built on Kepler's legacy, including the Transiting Exoplanet Survey Satellite, TESS, launched in 2018. TESS is surveying nearly the entire sky to find transiting exoplanets around the brighter stars, making it easier for follow-up observations. Meanwhile, the James Webb Space Telescope, JWST, set to begin operations soon, will provide unprecedented insights into the atmospheres of exoplanets, potentially detecting signs of habitability or even life. The discovery of exoplanets has profound implications for our understanding of the universe. It suggests that planetary systems are common and that the processes that led to the formation of Earth and the other planets in our solar system are not unique. This raises the tantalizing possibility that life in some form could exist elsewhere in the cosmos. As technology advances and our observational capabilities improve, the study of exoplanets will continue to be one of the most exciting and dynamic fields in astronomy, bringing us closer to answering the age-old question of whether we are alone in the universe.